In the next example, we want to find the intervals where this function, y equals x squared minus 2x minus 3, is positive. So we know that this is a parabola. What else do we know about this parabola? We also know that it opens up, I believe, right? Yep, a is positive. So this is some sort of parabola that opens up. Now, when we're talking about positive, we are looking for places where it is above the x-axis. I don't know why I can't write there. That's super weird. Okay, so we're looking for places above the x-axis. So what determines whether it's above the x-axis is the intercepts. That's what we really want to find, is the intercepts. Okay, I'll show you what I mean here. So to find the intercepts, we are going to go into intercept form, which is just the factored form. Okay, so we know that the signs are going to be different. We're looking for factors of 3 that add up to -2, so 3 and 1. And if we set these both equal to 0, we get x equals 3 and x equals -1. So what this means is this has intercepts at -1 and 3. Okay, this is a parabola, and we know this is where it crosses. And it opens up. We know that because the a value out front is a +1, so I don't really care what the rest of it looks like. That's the graph. So what we are supposed to find is, where is this positive? On what intervals are we above the x-axis? We'll notice here and here. So everything prior to -1, so from -infinity to -1, and then everything after 3, so from 3 to infinity. Those are the intervals in which this is positive. What that means is that if you pick a number, let's say you pick 5 and you plug it into here, you're going to get a positive number. Or if you pick a number in this interval, -1 or below, so if you plug in -8, you're going to get a positive number. Okay, so that's what that means. All right, let's try another one of these. We want to identify the intervals on which this is negative. So this time we're looking for negative. So everything hinges on the intercepts. So we're going to factor this, get it in intercept form or factored form. So we're looking for, oh, these are opposite signs. We're looking for factors of 21 that add up to -4. -7 and 3 sound good. We're going to set these both equal to 0. And we get 7. And we also get -3. Okay, so what that means is our two intercepts are -3 and 7. 1, 2, 3, 4, 5, 6, 7. I don't know if I counted that right. Also, our a value is +1, so we know this opens up. So whatever it looks like, I don't really care. Looks like this. Now this time, we are supposed to find the intervals where it's negative. So where it's below the x-axis, and that happens from here to here. So that happens everywhere between -3 and 7. So that's our answer, between -3 and 7. What that means is if you pick a number between -3 and 7 and plug it in here, you're going to get a negative answer. All right. Put this all together. We want to write an equation of a parabola with intercepts at -2, 0, and -1, 0 that also goes through this point. So if we go way back to the front of this thing, I don't know if we can get there. It's taking forever. There we go. Okay. This factored form, remember, if we know the x-intercepts, P and Q, we can find the factors of that. Okay, so that's what we're going to do. Now, it may have this number A out in front, which we'll have to deal with that. So we'll figure that here in a second. So back to our last problem. I guess we gotta get there. All right. So what this is telling us is we know that we have an intercept at -2. That means this comes from a factor of, it's the opposite of that, x plus 2. And we have an intercept at -1. That means it comes from the factor x plus 1. Okay, so hopefully you can see if you take this x plus 2 and set it equal to 0, that gets you that -2 that we were talking about. And if we take this x plus 1 and set it equal to 0, that gets you that -1. I don't really want to do that, so I'm erasing that. Okay, but if you are given the intercepts, what is happening? I don't know what just happened there. That was super weird. If you are given the intercepts, you just take the opposite of them, and those are the factors. So we are in really good shape, but remember there could be this number a out here, and we don't know what it is. We still need to figure out that a. So to figure out that a, we're going to do kind of like we did way back at the beginning. We're going to plug in this point xy, and we're going to use that to solve for a. So we know that y is 20. We don't know what a is, but x is -3. So we have -3 plus 2 and -3 plus 1. So that gives us -1. My computer is like revolting. Won't do this anymore. All right, so we get 20 equals -1 times -2 is +2. And so when we divide, we get a equals 10. Okay, so now we're going to come back, plug that right in there. Our answer is 10, x plus 2, x plus 1. Here's our answer. Let's do one more like this. We have a parabola with intercepts at 3 and -3. So if it has an intercept at 3, that means the factor that it comes from is x minus 3. It's opposite. And -3 comes from the factor x plus 3. So this might be our equation, but we might have a number out in front, this a. We don't know what that a is. We got to figure it out. So we're going to plug in this point, xy, and we're going to use that to find a. So we have 2 equals a, x is 1, so 1 minus 3, and 1 plus 3. So 1 minus 3 is going to be -2, 1 plus 3 is going to be 4. So we get -8a. Divide both sides by -8, and you're going to get a equals -1/4 once you reduce that. So now that we know that a is -1/4, we get y equals -1/4 x minus 3, x plus 3.